right, so today we're going to talk about dividing polynomials. And in order to do that, I thought it would be helpful for us to think about dividing numbers. So if we think about dividing 11 by 4, 11 is what we call the dividend, and 4 is what we call the divisor, and we might write it like this. And I would ask myself, does 4 go into 1? No, so then I would change my question, does 4 go into 11? And if so, how many times? It does. So 4 goes into 11 2 times, and that would give me 8. And so I can see that my remainder is 3. And so when I write this out as a mixed fraction, I have 2 wholes that it goes in, 2 whole times, and then 3/4 of a time after that. I take that remainder right here, and I write it as a fraction over my divisor. So we're going to use that same strategy when we're dividing polynomials. So when we are dividing polynomials, we are going to use the area model, and this part right here is going to be what we should get inside the box. And if you think about our example up here, same idea kind of, right? That 11 went inside. And then this part is going to go outside the box of our area model. And we're going to ask ourselves basically what would multiply by this x squared minus 4x plus 10 to give us the x cubed minus x squared minus 2x plus 30. And when we do these, we never necessarily know how many times it'll take. So when I set it up, I'm going to put this part that I said is going to go outside the box. And I'm going to set it up. And I'm not really going to end this box. I'm just going to start it so that I can figure out how far we need it to really go. So what our goal is to figure out what do we need to multiply this by to get this. And so I'm going to start by thinking about that x cubed, right? Let's just start there. What would I need to multiply x squared by to get x cubed? Well, we would need to multiply by x. And then anything, if I'm going to multiply by x, everything would get multiplied by x. So that actually allows me to fill in these 2 boxes. So I get negative 4x squared and 10x. So this is kind of like a puzzle. You're always trying to figure out what you can fill in next. So the next thing I know is that I want to get, my next term that I need to get is that negative x squared. And right now, if you take a look, right now we have negative 4x squared, and that's going to combine with whatever is in this box. Right? So those are going to combine. So what needs to go in that box so that I get negative x squared? Well, if I put a 3x squared in this box, then I will get that negative x squared that I need. Well, now that opens up a whole new set of options for me. What does x squared need to multiply by to get 3x squared? It needs to multiply by 3. And so I'm going to ask myself, well, okay, now 3 is going to multiply by all of these things, right? So 3 times the x squared gives us the 3x squared. 3 times the negative 4x gives us negative 12x. 3 times the 10 gives us 30. So now, keep in mind that all of these terms right here that are the like terms, right, something x, are going to combine to give me this next term, negative 2x. So what needs to go in this box, this last yellow box, so that I get negative 2x? Well, 10x plus negative 12x is actually already negative 2x. So I don't want there to be any more added to that. So I want there to be 0 more so that I get that negative 2x that I'm hoping for. And then when I look at the very last grouping, right, I know that this will combine with this, And if I ask myself, well, what needs to go here so that I get this last term of 30? Well, again, nothing. I don't want anything. I already have 30. So this set of boxes is actually my remainder. And here's how I know that. If I were to ask myself how many times does this x squared need to multiply in to get a 0, that doesn't really make any sense, right? I've already kind of used all the types of terms here. So what does this mean when a remainder is 0? It means that it divided evenly, which means that this solution, x plus 3, is a factor of the cubic. So whenever I get a remainder of 0, it tells me that it divides evenly, which means that x plus 3 would be a factor. Now let's take a look at one where we do get a remainder. So I'm going to set this up again. Here's what is inside the box. Here is what is outside the box. And so I'm going to set up that x squared, 3x, and 1. And I'm going to set up my area model. And I'm just going to give it as much space as I need, right? And I'm going to just start with this first term, 2x cubed. In order to get a 2x cubed, what would I need to multiply x squared by? Well, I'd need to multiply by a 2x. Okay, well, if I'm going to multiply by a 2x, everything would get multiplied by a 2x. So that would become 6x squared and 2x. And so again, I'm going to look at these diagonals to figure out how I would get this negative 3x. Well, that's interesting because negative 3x is my next term, but right now I'm talking about x squareds. So I actually have to undo that, and I have to think about, well, what is this x squared term? It's a 0x squared, right? We don't want to have an x squared left. So what would have to go in this box right here so that we get a 0x squared? Well, we would have to have a negative 6x squared to cancel that out. So now this allows me to start again, right? What would multiply by x squared to get a negative 6x squared? Sorry, you probably hear my dog in the background. It would need a negative 6. And that negative 6 would multiply by everything. So that would give me negative 18x and negative 6. Well, let's look at our next set of diagonals. 2x, negative 18x, and whatever goes in this box right here would need to combine to make my negative 3x. So right now I have negative 16x, and I want it to be negative 3x. So what do I need to put in that blank? I need to put a positive 13x so that 2x, negative 18x, and 13x would give me that negative 3x. And now I can start asking myself, okay, well, what would I need to multiply x squared by? You really can hear my dog in the background. I think she's choking up her dinner here. What would I need to multiply x squared by to get a 13x? Well, here's how I know I'm done. I can't think of anything that would multiply by x squared to give me 13x, right? It would have to actually divide by something to get that. So that's what tells me, oh, this column is going to be my remainder. So that's great to know because now I know this is my last column. Okay, so let's take a look. What about this? Negative 6. If I have this negative 6 here, it's going to combine with whatever is in this diagonal spot to get this 5. So what would need to be there? Well, we would need to have a positive 1. Actually, no, we would need to have a positive 11 so that when they combine, they make a positive 5. And so now I can see that when I divide 2x cubed minus 3x plus 5 by x squared plus 3x plus 1, I get 2x minus 6, And then I get this remainder. And just like before, looking up here, right, I want to take that remainder and write it over our divisor as a mixed fraction. So I would get 2x negative 6 plus my remainder, 13x plus 11, out of that divisor, x squared plus 3x plus 1. And this would be my final answer. So let's just put this into context. What that means is that this right here multiplied by this would give us this right here. So we were able to identify what we get when we divide those. So those two examples, the goal was just to practice dividing, doing polynomial division with the area model. And now you might be wondering why you might ever care to do that. And the reason is that until now, we have not learned how to factor things like this. We've only learned how to factor quadratics, and that has limited us, so we can only solve polynomials if it already is factored into quadratics. In this polynomial in standard form, we couldn't solve this before, but now we can. If we're given a factor of a polynomial, we can use it to divide out that polynomial and then factor what's left. So let's go ahead and give this a try. So in order to do this, I want to divide out this factor so that I'll have a quadratic left that I can factor further. Okay, so let's think about what this looks like. I'm going to have 2x plus 3 on the outside. And I should get this on the inside, right? So I'm going to start with that 6x cubed. 2x times something would have to give me 6x cubed. So that would have to be 2 times 3 to get 6, and x times x squared to get the x cubed. So it'd have to be 3x squared. And that 3x squared would also multiply by the 3. And so that would give us 9x squared. Now, we know that this 9x squared is going to combine with whatever's in this spot to give us the x squared term here. So we might ask ourselves, well, what has to be there? 9x squared plus something has to give me that 31x squared, so that has to be 22x squared, right? Now I can start my process over again. 2x times something has to give me 22x squared, so I'd have to multiply by 11x to get that 22x squared. And that 11x is also going to multiply by the 3 to give us 33x. Now thinking about that 33x, remember it's going to combine with its like terms to give us 25x. So what has to go in this next spot? If I'm thinking about that, 33x and I only want 25x, I need to subtract 8x here. Right? So that together they'll make that 25x. So now I'm asking myself, okay, so 2x times something gives me negative 8x. That's got to be a negative 4. And that negative 4 would also multiply by the 3. And that would give me that set of boxes. And then, oh look, I know that right here, this negative 12 would combine with whatever's in this box to give me negative 12, but I don't want it to combine with anything because I already have exactly what I need. So that tells me that my remainder is 0, which is great because they told us that this was a factor, right? That's what they said right here, given that 2x plus 3 is a factor. If it's a factor, I should get a remainder of 0. If I didn't, I would know that something went wrong in my division process. So what this tells me is that I could take this cubic function right here and I could rewrite it and say that it factors into 2x plus 3 times 3x squared plus 11x minus 4, right? I know that this times this gives me my original cubic function. So why did this help me, right? Let's think about that. I did not know how to factor this straight away, right? I couldn't just factor that. So I divided out this factor they already gave me. Now I have something that I can factor myself, right? I can try to factor this 3x squared plus 11x minus 4. So I'm going to do that. Let's do that over here. We're going to use the area model again, just like we have been, right? Think about that area model. We're going to put that 3x squared and the negative 4, and I should get 11x from my b terms here. So what multiplies to make 3x squared? Well, a 3x and a 1x. What multiplies to make negative 4? Well, that could be a 1 and a 4 or a 2 and a 2, where one of them is negative. But I'm trying to get this 11x total, so I need a pretty big number. If I put 4 here, I would get 12x. That's good. I would like that, right? But this has to be a negative 1, because 4 times negative 1 is negative 4, and that would give me negative 1x, which does give me that 11x middle term. So I can go back to this function here that I have, f of x equals, and now I have my factor 2x plus 3, and I took this quadratic and I factored it further into 3x minus 1 and x plus 4. Now I'm looking at this, asking myself, can it factor any more? No, these are all degree 1 factors, right? So they can't factor any further. So when this asked me to write it in completely factored form, I used polynomial division so that I could figure out what this other quadratic factor would be, and then I finished factoring using the factoring methods we already know. Okay, so I recommend that you give this a try with the additional practice and check it with the key that is available online.